Hello and welcome to our second discussion on sampling distributions. Today we're going to talk about sample proportions. So let's give a quick example of a sample proportion. So a survey of 502 teenagers found that 210 could correctly identify the date of 1492 as the year in which Columbus discovered America. And so the sample proportion should be our statistic in this case, would be that proportion that could correctly identify 1492 as the year in which Columbus discovered America was 210 out of 502, or 0.42 or 42%. So let's talk about sample proportions. And so we're going to do that by talking about the sampling distribution of P. And then we're going to use a normal approximation for the statistic P. All right, so those are the two things we're going to talk about. And this is going to be, again, on the shorter side. So the question again is, how good is a statistic P as an estimate of a parameter P of the entire population? All right, so we're trying to, because we can't evaluate an entire population, we're going to take a sample, we're going to look at the sample, and then we're going to evaluate whether or not we think that that statistic accurately represents or is an unbiased estimator, in this case, the sample proportion or the population proportion. And we learned in the last lesson that the spread of the distribution of a sample gets smaller and the shape becomes more symmetric as its sample size increases. Right, so remember we had that sample size between 100 and 1,000, and as we increased from 100 to 1,000 for the sample size, then that statistic more accurately and more frequently represented the actual population proportion or mean, and the variability went down. All right, so let's talk about, and we're going to go through this again, some of the conditions that need to be met so that we can take a sample proportion and use a normal distribution to evaluate the quality of, or the accuracy of that sample proportion. So there's some things that we need before we can evaluate the sample proportion to determine whether or not it's an accurate representation, unbiased estimator. And these are the conditions that need to be met. So the first is the shape needs to be a normal curve, and we can assume that it's normal when both the count of the sample size times P is greater than or equal to 10, and the sample size times 1 minus P is greater than or equal to 10. All right, so then we can say that the curve for the sample is a normal curve. Additionally, we can use the equation for standard deviation of the sample proportion as P times 1 minus P over N when that condition for the 10% condition is met. And we're going to go through this again, so don't worry if you're not getting this right now. But just as a review, we need to have some conditions met: shape, center, and spread. Shape for the normal curve, NP and N times 1 minus P greater than or equal to 10. We're going to use the mean of the sampling distribution to represent an unbiased estimator of the population. And then we said that the standard deviation of P gets smaller and smaller as N gets larger. All right, so I should say standard deviation of the statistic gets smaller and smaller as N gets larger and larger. And you can see this as N gets larger and larger. The standard deviation, therefore, is going to get smaller and smaller mathematically. Okay, so we're going to skip through this. This will be some of your classwork in class. And we're going to talk about using the normal approximation for P. And I just had to change this P to the statistic or the sample proportion. All right, so again, so we're going to use a normal approximation for p hat. All right, so we can make inferences about the population. So we're talking about conditions now before we get into evaluating. So we need to make sure the conditions are met. And in an FRQ, you need to make sure that you show or demonstrate that the conditions are met before you do the evaluation. All right, so the first condition, we need to make sure that the distribution is normal. And we can say it's approximately normal when n times 1 minus p and np are both greater than or equal to 10. The sampling distribution of the population proportion will be approximately normal. All right, so that's the first condition. All right, so let's go through an evaluation. As an example, a polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. We're going to suppose it's 35% of all first-year students attend college within 50 miles from home. So that's the population proportion. What is the probability that the random sample of 1,500 students will get a result within 2 percentage points of this true 35% value? All right, so we want to find the probability that that population proportion, that statistic, falls between 0.33 and 0.37. All right, so we're going to collect and evaluate the data. So the first thing is we're going to say that the mean for the population, which is given as 0.35, and then we're going to evaluate the standard deviation. Standard deviation is p times 1 minus p over n, the square root of that value. And we're going to evaluate that number as 0.0123. And then we need to verify that in order to use that standard deviation model, we need to make sure that we've met the 10% rule for independence. So that standard deviation formula is valid only if n is less than or equal to 1/10 n. And so because there are approximately 1.7 million students and we're only drawing an SRS of 1,500, then we know that this meets the criteria for independence. We can use the standard deviation formula and we can use a value for standard deviation. Okay, so second is we've done the data collection and evaluation. We've determined that we can use the standard deviation formula because that sample meets the 1/10 or the 10% rule. Now we have to determine if we can use a normal distribution to approximate the sampling. And both NP and n times 1 minus p are both greater than or equal to 10. All right, so we can assume approximately normal distribution because they're both greater than 10. All right, so now because the conditions are met, we've evaluated both the 10% rule and the normal distribution rule, or approximately normal distribution. We can evaluate the requirement, which is to see what percent of the SRS will give a result within 2 percentage points of the true value. Okay, so conditions are met. We've evaluated the standard deviation. We have a mean. And so now we're going to find the desired probability using standardized values. And so the first value is the lower end statistic of 0.33, and the upper end p sub 2 is going to be 0.37. So 0.33 and 0.37. And so we're going to find the lower end first. So we'll call this Z1. It's going to be 0.33 minus 0.35, which is that value, which is the population mean, over the standard deviation, gives us our Z score of negative 1.63. And similarly, we have a positive 1.63 for the upper end limit. And so we can evaluate what percentage of the values are going to fall between 0.33 and 0.37 based upon our Z scores of negative 1.63 and 1.63. Right? And so what we get is approximately 0.8968 or 90% of sample sizes of 1,500 that will give a mean value within 2% of the population mean. Right? So all we're doing is we're trying to figure out, based on the sample size, what proportion, or what percentage of the sample sizes with 1,500 as a count will give us a probability that's between 0.33 and 0.37 when we know that the population proportion is 0.35. All right, and we get about 90% of the sample sizes. So only 10% of sample sizes would fall outside of 0.33 to 0.37. All right, so this brings us to your homework problem. I believe this is the only one. I could be mistaken. So superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year, I should say high school students, are planning to attend a four-year high school or a four-year college or university. Suppose that 80% of all middle school students in the district are planning to attend a four-year college or university. What is the probability that an SRS of 125 will give a result within 7 percentage points? All right, so it's your responsibility now to state the objective. We're going to do state plan, do conclude, verify that the criteria are met, do the calculations, and then conclude based on the calculations what percentage of the SRS of 125 will give that result within 7 percentage points. Okay. All right. So I think that is going to be the end of this discussion. And that's it. So please copy this down. I'm going to leave this up here for just another couple seconds, and then we're going to conclude the video. Thanks very much for joining us. Come back next time. We're going to talk about the last section. We're going to talk about sample means in 7.3.